Today we are going to discuss functional programming principles using Pandas and Python. So here's more of your traditional approach of iterating over data. You have some data, you iterate over it row by row, you make some calculations and some sub-aggregations, you make some final aggregations, and you have your results. Here is more of a functional method where you get your data here and you're applying these anonymous functions to subsets of your data. In this case, your date column. Here you're aggregating your data, grouping it by and summing. And here you're applying a predefined function that will give you a weighted average close price over all the different rows of your data frame. So this code's more compact. It has a bunch of different built-in functions and a bunch of different transformations you can do that comes out of the box. Where here you're going to have to write all the code yourself, which if you have a lot of work to do, this is going to save you a ton of time. So what are we getting out of this, and what's the best way to use this library? So I have a couple of easy examples, very simple examples here. The traditional iteration of going over the data frame takes about 32 milliseconds per loop, where using apply to apply functions, very similar functions, actually only takes 0.34 of a millisecond, so it's 1/100th of the time it takes to use iteros, where a traditional loop is actually the fastest, and it's at 0.12 of a millisecond. So this tells us if we have a well-defined and simple problem, then we should just use traditional out-of-the-box methods and out-of-the-box objects. But if we have something more complex where we would have to write a lot of code and spend a lot of time developing it, we can leverage these different built-in aggregation functions and functionality and transformation functions that come with Pandas to be able to get up and running faster and to do the work for us quicker.